In this video, we'll be looking at scientific notation, standard notation, and calculator notation. The first problem, we're going to convert 61,200 to scientific notation. To write a number in scientific notation, we have to write the number so that it's a number between 0 and greater than 0 but less than 10. We're going to start out with a decimal point furthest to the right, and we're going to have to move it between the 6 and 1. So we can start out by writing 6.12. We don't have to write the other zeros. Then we're going to write it times 10 to some power. That power indicates the number of places that we move the decimal. We move the decimal 1, 2, 3, 4 places. Since it's a large number and that is a small decimal number, the exponent will be a positive 4. B, convert 0.00000000345 to scientific notation. Obviously, that was a lot of zeros in that small decimal number. So again, we're going to have to move that decimal place between a number that's greater than 0 but less than 10. So I'm going to put the decimal place between the 3 and the 4. So I'm going to rewrite this as 3.45 times 10 to some power. Let's see how many decimal places we moved it. We moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. That 10 will go as the exponent 10. Since it's an extremely small, minuscule decimal number, we're going to say that exponent is negative. Now convert 2.5 times 10 to the 7th to standard notation. So we're going to have to expand it back out. Since it's a 7 as the exponent, that means we're going to write this number as a larger number. I'm going to take the 2.5, I'm going to rewrite it over here, and I'm going to just move the decimal place. And the exponent tells me the number of places to move it. I'm going to move it to the right since it's a large number. 1, 2, 3, 4, 5, 6, 7. I moved it 7 places because of the exponent of 7. I fill in the rest of the numbers with zeros, place values 1, 2, 3, 4, 5, 6. And so that number will end up being 2, 5, 1, 2, 3, 4, 5, 6. So there you go, 25 million. That's our final answer. Our next problem, we're going to have to convert 8.35 times 10 to the negative 5th to standard notation. First of all, I'm going to write 8.35 down, and then I'm going to have to move the decimal place 5 places, and this one, I'm going to have to move it to the left. Oh, I didn't leave myself enough room. That's okay. We'll write over the answers. Let me rewrite 8.35 below. Move it place to the left, 1, 2, 3, 4, 5. 1, 2, 3, 4. Fill in the rest with zeros. So now my final answer is going to be 0.1234835. And that will be my final answer. That's in standard notation. Our last two problems deal with calculator notation. Sometimes in the calculations, when you get a calculator answer, it'll have this funky little E symbol, 7.25 E negative 4. 7.25 E negative 4 is a fancy way of saying 7.25 times 10 to the negative 4th power. Remember how we convert it to standard notation then? We're going to write 7.25 and move the decimal place 4 places, and then we're going to move it to the left. So 1, 2, 3, 4. Fill in the rest with zeros, and our final answer is going to be 0.000725. Our last problem, 3.4E6. We can rewrite it as 3.4 times 10 to the 6th power. So I can rewrite 3.4, move my decimal place 6 places to the right since it's a large number, 1, 2, 3, 4, 5, 6, because the exponent is 6. And my final answer is going to be 3, 4, 1, 2, 3, 4, 5 zeros. So it's going to be 3,400,000. Again, the last two here, converting from the calculator notation to standard notation, you'll have to know how to do for the class.